To Git. My name is Levi Zitting. I'm going to be presenting on the topic tonight. I'm split this presentation into two different sections. So kind of the first part of this presentation is I'm going to kind of set up the problems that Git really helps us solve. So we're going to go through a couple of scenarios that you'll run into in the real world as you're developing software. And then kind of the second half is we're going to break down how Git can be used to solve those problems. So, also afterwards, I'll be hanging around if anyone has any questions, needs any help with anything. I'm gonna try and go slow enough that you can follow along on your own computer and kind of type these commands as we go. But if you get lost, it's okay. Just once again, I'm gonna be hanging around for a little bit afterwards while I'm tearing down the streaming stuff and all that kind of stuff. So hang out if you have more questions. So let's get in. Let's kick this off and let's talk about some of these scenarios that I had come up with. So. Let's say you are ready to start writing your first ever program that you're going to release out into the world. You want other people to use this thing, right? And we're not going to get into the complexities of releasing software by any means. Just imagine that we have that side of things figured out. But you sit down to write the software, you crank it out in a weekend, you anticipate that you're going to make updates to the software in the future, right? You're going to fix bugs, you're going to add features, you're going to streamline things, you're going to refactor your code, you're going to update it, right? So you release this software and then you get started on some of those updates, right? You know that there was some problems in the initial version you released, and so you get started on fixing those bugs, right? Well, let's say a few weeks go by and people are using this piece of software out in the real world and they start emailing you about some problems they're running into and they'd like you to fix them. And when you go to sit down and try and figure out these problems that these users are talking about, you don't have a clear view into your software because you've made changes to it since then. The project is not in the exact same state as it was when you released it into the world. And so trying to figure out problems that people have in the version that's being used can become kind of a hassle. It can be a little bit of a pain. Now, a lo-fi solution to a problem like that might be just to, every time you make a release or you release a new version of your software, you right-click on your project's folder and you copy it into like a archives folder or something like that, or you zip it up. But even that is still a little bit cumbersome. You start to clutter up your computer with all these old versions of your software, and there's not really an easy way to just jump back to another version really quick. You have to kind of go digging and go hunting for that specific version. So that's kind of scenario number one. That's not really a great experience, and it can cause a lot of problems for you as the developer. The second scenario that I'm going to walk through really quick is that of collaboration. And this scenario is actually more of a personal story. So when I was first getting started coding several years ago, I was back in high school, and me and a friend of mine were entered into this website design competition. And like the good high schoolers we were, we put it off until the final weekend it was due, right? So we're sitting there this weekend and we need to crank out some code. We want to split up the tasks between each other so that we can be super efficient and get this thing done on time. Now, because we want to do things fast, that means we don't really want to work on the same computer, right? We're doing a kind of a basic website, so there was a couple of different pages. I could be building out one page while he builds out another page, right? And so back then I had kind of heard of Git before, but I decided that I didn't have enough time to try learning it. And so we came up with a little bit of a different solution. We both installed Dropbox on our computer, and we set up a shared Dropbox folder. And that way, any change one of us made would automatically be synced over to the other. And that worked okay, but there was definitely some problems. So probably the first problem that comes up is what happens if we both are editing the exact same file. You know, we're working on this website, we have a shared CSS file between all of the pages on this website. And if I was editing it, I had to make sure and tell my friend, hey, I'm opening the CSS file, please don't touch it for a few minutes. And then of course we would forget and we'd open the file anyways. And whenever that happens, usually something like your editor throws a big error and says, the file changed, and it saves maybe a backup of the one you were working on. And then you have to sit there and open that backup and the original and go through and manually put these changes back in order, which is a huge hassle, takes up a lot of time, and gets in your way, totally disrupts your workflow. The other problem we ran into all the time was if I was working on some change on my computer and I was ready to go test it in the browser, I would save all my files and go look at the browser. Little bit notes to me, I had written some really bad code that totally broke the website. Guess what? That bad code ended up on my friend's computer and broke the website for him and disrupted his workflow. So this shared Dropbox folder was actually kind of more detrimental. It was definitely easier than us sending files back and forth between each other, but it still wasn't seamless. We couldn't control when changes went out to the other person or when we were ready to accept the other person's changes. We had no visibility and no control into that. So this problem that I'm talking about here is known as version control. We need to be able to control the versions of our software or the revisions of our software. And that's primarily what Git does. So Git is what's known as a version control system. It's also been known as maybe a source control management system. Those terms are fairly interchangeable. But Git is a solution to this exact problem here. It allows developers to keep a complete history of their project and also allows developers to collaborate with each other without always getting in each other's ways, like we were doing with that Dropbox scenario. Now, Git is not the only solution to this problem. There's a few others. Microsoft has one called Team Foundation Server. There's one called Apache Subversion, or SVN for short. But none of those are near as popular as Git. Almost everyone is using Git today. And so if you're going to learn any version control system, Git is probably the one to learn today. Excuse me. Okay. So I want to start breaking down Git. So now we've gone through some scenarios. Hopefully you can see that there's an obvious problem here. And we're going to break down how Git solves this particular problem. And to do that, we're going to walk through kind of a how-to guide, how to use some of the basics of Git. To start, we need to install Git. So if you don't already have Git installed on your machine, you can go to git-scm.com and go to the downloads page. And they have downloads for all the major operating systems. If you are on a MacBook or any Mac OS device, if you install the Xcode command line utilities, it will come with Git. There's also a couple others, but this is kind of the main way to get Git. Sorry, I promised myself I wasn't going to make too many puns. Okay, so hopefully you have Git installed at this point. And one thing that you might notice if you're not familiar with a command line, if you've never heard of that term before, which once again, I'm not expecting any previous knowledge here, you might notice that if you try and install Git, there's no shortcut on your desktop to open up. There's no application to start up and click on. And that's because Git isn't a normal desktop application. Git is what's known as a command line tool. And if you've never heard of a command line, if you've primarily just been using a computer in the past probably, 15, 20 years or so, you're probably really familiar with the user interface, with the ability to click on buttons and close programs and open new programs that way. But before all of that existed, all we had to interact with our computers was just text. And you entered commands into these computers and it would do things, right? And when we install Git, all that Git does is add an additional command for us to use in our command line. That's the primary way of interacting with Git. So what I'm going to do is, I already have Git installed on my computer. Oh, we are not, the thing isn't even down. Whoops, 1 second. Totally meant to pull that down earlier. It might screw some stuff up over there. Okay. Is anything showing up? Oh, it's warming up. Give it a second. Yeah, thank you for turning those lights off. Still not getting anything. Okay, can you guys see that now?
Not really. It's getting there.
Still kind of warming up a little bit, maybe. It's okay if we have to turn most of the lights off. Can you see that now?
Yeah.
Okay.
When you start typing.
Can you see that pretty clearly?
Yeah.
Oh, yeah.
Okay, cool. All right, so back to command lines and all that kind of stuff. So this right here is the command line I've opened up on my computer. If you're on a Windows laptop, you would open up the program PowerShell or maybe Command Prompt. Either one of those would work. And if you did everything right when you were installing Git, you should be able to type git -- version, and you should see something similar to that. If you get some kind of error, then you didn't really install Git properly. And if you were trying to follow along here, you can talk to me afterwards and I'll help you figure out what went wrong. Okay, so now we have Git installed, we can interact with it. And so kind of the rest of this presentation is going to be talking about some of the basic commands that you can use alongside with Git. And there's a couple of topics, there's kind of 4 big topics that I want to talk about kind of as we're going through some of these commands. So the first kind of big topic with Git to talk about is what's known as a repository. And as I mentioned earlier, Git is a version control system, and which means that, another definition is maybe a piece of software that tracks changes to our project over time. Keyword there being tracks, right? And so for Git to actually do any tracking, it needs a place to store all of the information about these changes, right? And so that thing that Git stores everything in is known as a repository. So I'm going to start by setting up a blank project essentially and creating a repository for Git to store all of my changes in. So this command cd stands for change directory. I'm going to go in here to my desktop folder and I'm going to make a new folder. We'll just call it my project. And you can see it showed up on my desktop right there. Now I'm going to go into my project. So cd my project. And I'm going to type a command to create a repository, and that command is called git init. So the first time you're setting up your project, and you need to create this repository for Git to store all of its information. So I'll type git init, and it ran something, and my terminal changed. Now, I use my terminal a lot, or my command line a lot, and I've done some customization to it, so it automatically recognizes when it is in a folder that contains a Git repository, and it does some extra styling for me here. And I kept it in here because I felt like it would provide some additional visual cues to kind of what we're doing here. But by default, you will probably not see this green section that says master. So I just typed git init. What exactly happened there? So I mentioned that Git created a repository, and how we can tell if there is a repository in a folder is we can look for a hidden folder called .git. This isn't super important. I'm just kind of saying this so that if you're ever wondering how to know if something is a Git repository or not, there's a hidden folder called .git. And by default, most operating systems hide any folders that start with a period. So there is a hidden folder in this folder. If I open up this in my file explorer, you'll see there's no folder in here. But with the command line, I can type a special command, ls-a, which stands for list all the files, including the hidden ones. You'll see it found this folder in here called .git. Also, if I think I open up my Finder on Mac, there is a thing to show hidden files. Yep. So I hit Command-Shift period, and then we can see that hidden folder there. And we never, ever, ever need to touch this folder. This folder is entirely managed by Git, and it is where Git stores, once again, all of that change information. So I'm going to go ahead and hide that again really quick. So now we kind of understand what a repository is. A repository is where Git stores its information. What kind of information does Git store in there? You might think, because it's a version control system, it stores the different versions. But Git has a special name for these versions, and that name is a commit. So every time you are ready to make a brand new version of your software, or you are ready to kind of bundle up the changes you've been working on and save them, that is what's known as making a commit. Another way I kind of like to think about it is it's kind of a checkpoint. Because one thing Git allows us to do very easily is roll back to any commit at any point in time. And so I like to think of making a commit as making a checkpoint, right? It's kind of the equivalent of us copying our entire project over to another folder like we did in that very first example. So how do we make a commit? So the first thing to make a commit that we'll need is some changes to our project. So I'm going to type another command here that simply opens up the current folder I'm looking at in my code editor. So this is Visual Studio Code. And right here on the left, all of my projects, folders, and files will show up here. And there's a nice little shortcut to create a brand new file. So I'm just going to create a new text file. I'm just going to call it test.txt. Nothing super fancy. We'll just say hello in here. I'm going to save that change. If I go back to Finder, you'll see that's the only file in here. If I jump back into my command line, if you want to check if Git has recognized that there's been any changes to your project, you can type git status. And that right there, Git is saying that there is a new file that has not been committed, or it's not tracking the changes to it yet, called test.txt. So now we have a change made to our project. We want Git to store that change somehow. And storing that change or making the commit is a two-stage process. There's kind of two steps to it. The first step here is known as staging. And then the second step is actually making the commit. So really, maybe you could think of it as a three-stage process. You first have to make some changes to your project. Then you do what is called staging those changes, where you stage all the changes, and then you actually make the commit. So this staging step, it was something that was very hard for me to understand when I was first getting into Git. And its primary purpose is to give us a little bit of leeway and control over what changes actually end up in our commit. Let's say that I had created 10 different files here, and I wanted it to show up in the history of all these versions that I added one file at a time. With the ability to stage the files first, I have that control. So to stage a file, I type, and maybe to really drive this example home, let's create another file called test2.txt. So we have a completely different file in here with a little bit of content. If I come back here, Git now notices that there's two files with changes. So to stage a file, we type this command, git add, and then the name of the file. So I'm going to add the first one, so test.txt. And at this point, now we have a change that has been staged, and we can make one of those commits that I was talking about. But once again, to talk a little bit more about this staging process, if we made a commit right now, and we were looking back at our history, the change would only show that the first file was added, because we didn't stage both of them. We only staged the first one. Once again, I understand if this is confusing, that's okay. This took me a long time to really understand. I'm trying to give some explanations behind it, but you also might not really get it until you've run into the scenario where you really want kind of some granular control over your changes. If you are a very beginner to Git, what you'll probably want to do is just stage every change you've made. And there's a nice little shortcut for doing that. You can type git add -A, and that adds all the files. So now when we make a commit, once again, if we're looking back through our history, this commit will show both of those files. And this is what you'll probably be doing most of the time. It's just staging every change. So back to making a commit. Once again, we've gone through this multi-stage process. We made some changes to our project. We staged them. Now we're ready to make the actual commit. Now there's one additional piece of information that Git needs. Sorry.
Could you also do git add dot?
Yes, that's another shortcut, I believe. I'm used to the git add -A. It's kind of the default in my mind. I don't know if there's any differences between the two. You'd have to Google that. But I do remember that the git add dot was another way to add all of them. So there's one additional piece of information we have to give Git. It's kind of like a required field, if you will, for making a commit, and that is providing a message. So I'm going to type git commit. This is the command to create a brand new commit. And then I'm going to say -m, and then inside of these double quotes, I'm going to provide a message. And I'm going to choose something just very simple, just call it first commit for now. I'm going to push enter here. You'll see everything went back to green because Git doesn't have any changes, and if I type git status again, you'll see Git says nothing to commit. But one thing to note here is with this message, it does take a little bit of practice, but you actually want to be somewhat descriptive in that message. Because if we think back to me talking about how Git is a history of our project over time, it is very, very beneficial to go back and look at that history at some points in time. And if you have messages that tell you what is happening for each of those changes, it is a lot easier to understand what's going on. It's almost kind of a way of commenting your code without actually commenting your code, right? You don't actually have to clutter in the code, but you can provide maybe reasons for making the change. At some places I've worked, if we were fixing a bug in this commit and we had like some project management software, we might put the ticket number or something in the commit message, so it was really easy to tie it back into another system. So a commit message like first commit is really bad. Probably don't do that. Try and be a little bit more descriptive. Something a little better may have just been simply add a couple of text files, right? Because that's actually what I was doing in this change. So now that we've talked a little bit about commits here, let's talk about the third big piece of terminology I want to go over. And that is remote repositories. So we talked a little bit about repositories. Once again, a repository is just all of the changes made to our project, and Git is storing and managing that. A remote repository is just another copy of our repository that lives somewhere else, maybe somewhere on the internet, on someone else's computer, that kind of thing. And there's a couple of really cool services that have come out, I don't know, in the past 10-something years that provide some of these remote repositories. And these remote repositories are what really allow us to collaborate with other people using Git. And so you've probably heard of the most popular one, and that is GitHub. So I'm going to go to GitHub really quick. And GitHub allows us, right here you can see there's this repository section with a brand new button. And essentially, underneath the hood, GitHub on their server is running git init somewhere and creating a brand new repository for us. So I'm actually going to create a brand new repository. We'll just call this my project, maybe the same as the one on my computer. And right here, it's not really showing any files in our project or anything like that because there is none. There isn't any. But there are some steps here, and these are basically kind of we can see in here it's running git init, and then and it's making a commit here, and then to really focus on is kind of these last two commands. So this command right here is kind of important. What this does, I'm actually going to copy this command here. I'm going to come back into my terminal, and I'm going to run it on my local repository here. So what this command does is it takes the repository that is on my computer right now, and it connects it to the one in GitHub. That's what this command right here does. So I'm going to run this. So now that it's connected, I can sync the commits that I made that are on my machine to the version of the repository that is up in GitHub. So that's kind of what this second command right here is doing. And I want you to ignore this -u origin master. Just focus on that Git push side of things. So I'm going to run this command. And now that it's done, I'm going to come refresh up here in GitHub. And you'll see we have the two test files that I had made on my computer. Now, once again, let's kind of go back and analyze this command. Totally forget about this little part right here. Just focus on the Git push. So this first command did what is called adding a remote. We don't really need to dive into that much farther. But essentially, you can think of it just connecting our repository to the one that's in GitHub. And then this git push command is what we do when we are ready to send our work or our commits or our changes back up to GitHub. This -u origin master isn't super vital to understand at this point. You only have to run it the very first time you do this. After that, you can just type git push. So we talked about how to push the changes we've made up to a remote repository. Now let's talk about collaboration for a second. So one thing I'm going to do really quick is I'm going to open up another terminal. And I'm going to put these, side by side. And, hopefully you can see both of those. And I'm going to come back into GitHub here. And I'm going to pretend like I am maybe a coworker, right? So me, Levi, is this computer. Let's pretend that this is my laptop right here. And this right over here is my coworker on a completely different computer. I'm able to do it on the same, but just imagine that I'm on a different computer when I'm typing inside of this terminal here. So I'm going to go to a different folder really quick, maybe my documents folder. So just so that I'm not working in the same directory. But once again, just pretend that I'm on a different computer here. So I'm going to come over to GitHub and I'm going to click on this clone or download button. And I'm going to grab this little bit of text right here. Now, if you're working with GitHub, that bit of text probably starts with HTTPS. I have some special stuff set up in how I'm authenticating with GitHub from my computer, so it looks a little bit different. And I can actually click this button and you can see that's what it kind of normally looks like. But I'm going to use this one because of the special setup I have. And I'm going to come in here and I'm going to type another command in Git called Git Clone. And then, once again, pretend that that is a URL. So what Git Clone does is it looks at a remote repository, copies it down to this computer, and makes that connection that I had to do manually in the other setup. And so now my coworker has my project with all the files in it, right? Exactly how I had. And so if I come over here, let's go back to the code editor, and let's make a change. So we'll say hello world here instead of just hello. If I type git status, we'll see that I've made a change to that test.txt. We'll go ahead and add that change or stage it. And then I'll make another commit here called update message or something like that. And now once again, the command to push the things that are on my machine up to GitHub is git push. And if I jump over to GitHub really quick and open up this file, we see my change there. So now I'm my coworker and I'm ready to pull in all of the work that I did. My coworker is ready to pull in all the work that I just did. Ready to sync back down. Remember back to that Dropbox example, how I mentioned that we had no control of when changes went out and when we pulled someone else's change in? This is exactly that bit of control that we need. So back in my coworker's computer, the command that they would use, go ahead.
You gave to your coworker the clone link, right?
Yes. That's kind of what you can think that is. Yep. Or, partner on my project, whatever. Just someone I'm collaborating with, yeah. So then my coworker or partner or whatever, to pull the changes I made into their version of the repository on their computer, they type Git Pull. And we'll see here, I didn't show you the version of the repository that they had, but now they have that change that I just made. So is there any more questions on this kind of remote repository? Go ahead.
Yeah, I follow the steps, but it says please make sure you have the correct access rights and that the repository exists.
Okay, I'm not going to go through this in the presentation, but you have to, I was afraid we were going to run into this. The version of Git you have on your computer has no, how do I word this? It isn't authenticated with GitHub, right? You have a GitHub account on GitHub so that no one can, you don't want to just make it so anyone can make changes to your projects, right? You want to be able to delegate some access there. And so right now, GitHub is seeing your computer as just a random stranger. It's not seeing it as your GitHub user. So afterwards, I can help you figure that out. I didn't put that together for the slides. So sorry if you won't be able to follow along for this little portion. But that's exactly why that problem is coming up. I'm glad that you ran into it so that everyone else understands that if they run into it. Okay, so remote repositories. I'm going to pause for a second and ask if there's any other questions.
Does, I guess on this level of working, do they get notifications of changes?
So if you are, I'm glad you asked that. So services like GitHub, there's another one called Bitbucket out there that works primarily in the same way. Those services have built kind of notifications around this process. So at lots of places that I've worked, we normally use Slack, and there's usually some direct integration between GitHub and Slack. So we'll have a Slack channel for our project where every time someone pushes up a commit, a new message shows up in there. And so that's one way to do it. I know that there's also built-in ways in GitHub just to get email notifications about brand new commits that are coming in. Great question. Okay, so.
We got another question.
Oh, sure.
So when your partner does the Git pull, if they happen to change the exact same file, will it'll overwrite their file, their copy?
No, but I'm glad you asked that because that's a little bit about what we're going to get into next. Before we jump into that specific example, first to answer your question, absolutely not. Git does its absolute best to not overwrite anyone's work ever. And in some cases, as you're using Git, that might get a little bit annoying for the reasons we'll get into in a minute. But before we talk about that example, I want to talk about a little bit of a different example. So let's say I'm not going to actually type out the commands here, but just imagine for a second that while I'm over here working, I make a commit to the project and I push it up. And then while my coworker is working, they're working on some other change, different files completely, and they make a commit before they pull my commit into their project. And then they try and push their commit back up to GitHub. So what GitHub just saw is I made a commit, and then my coworker tried to make a commit maybe before mine, and Git has a huge problem with that, because at the end of the day, this history has to be kind of a straight line almost. You can't just interject things wherever you want. You can, but you have to manually do that kind of stuff, and services like GitHub don't do that automatically for you. I'm not going to walk through the kind of headache you would get into for that specific scenario, but I'm going to talk about a way to completely avoid it. And then after we're done talking about that way to avoid it, we'll get into the file question you had. So how you avoid this problem is using a feature of Git known as branches. So is there a marker up here? Hopefully you guys can all see this. Remember that all these commits are a history or a timeline, right? So each of these dots I'm drawing up here represents a commit I've made to my project. And like this is the very first one right here. And then you can draw a straight line between them, right? It's a timeline of events that have happened to your project in some way. So what's really cool is branches. If you're thinking about this as time, maybe, hopefully this doesn't get too complicated. Branches are essentially alternative timelines. We're getting into some crazy time stuff, right? So at any point in time, while you are at your project, so let's say, this is the latest commit, you can create a branch which literally makes just another timeline. And that other timeline has its own commits that are completely separate from this main timeline's commits. Does that kind of make sense there? Hopefully that representation makes sense, even though it's crude. And then at some point in the future, this branch can be merged back in with the rest of them, okay? And this is how we avoid that problem of people both trying to make changes to this timeline. Because essentially that's kind of what you're doing when you're making commits, is you're altering a timeline. You're adding new things onto this timeline. And when people try and both modify the timeline at the same time, that gets really confusing and Git gets confused. So branches are how you short circuit this problem completely. And you can have as many branches as you want. The main thing is that every branch has a commit that it started from. That's kind of the most important thing. And then that version of your project is completely different there. It can have completely different files. The files themselves can look completely different. And what's really cool is at any point while you're working, you can switch between those branches. So let's kind of walk through how to make a branch. It's pretty easy. Now, one more thing that I'll mention. You might have picked this up already, but notice how my terminal says master here? That my terminal is showing what branch I'm on right there. And this main branch, by convention, is known as master. So if you ever hear the master branch, everyone's kind of talking about the original branch. So to create a new branch, I'm gonna kind of draw out what we're doing to this timeline as I write commands here. So I think we've made 2 commits so far. That sounds right. So here's our two little commits. So I'm going to come over here.
Have two committed files or two
2 actual commits, 2 changes. So this first commit here added both of the files, and then this one made a modification to a single file. Yep. So at this point, to create a new branch, I type git checkout -b, which the -b flag creates a brand new branch. And let's just call this alt timeline. Now, at this point, all that I've done is kind of this. Notice how there's no commit there yet. So I guess the next step is let's go back into my code editor and let's create a new alt.txt file. We'll just throw alternative timeline in there. Whoops, wrong terminal. So let's make another commit. We'll type git status. Yep, we see that new file there. We'll add that. Type git commit and alternative file. Okay, we've made this commit. So now we go back to our little representation here. Now we've actually made a commit there. Now, at this point, our coworker, they could make as many commits as they want to master, and none of their work will ever interfere with our work, right? They can continue on with that timeline. Now, let's say at some point, we're ready to merge our changes back in, right? So the process of doing that, and for just the sake of completeness here, let's just create a new file in master.txt. This command just simply creates an empty file here. So my coworkers, they're going to make a change to the project, which, okay. It's a good idea as you're making commits to make sure that you have the latest from the remote repository, so you kind of avoid that first problem that I mentioned. So I'm going to git add, git commit, add new file. Okay, and I'm going to push this up to GitHub. Now, remember that -u origin master from a little bit earlier? That's going to make a little bit of a reappearance here, and this will kind of explain what that part of the command was doing. Let's say I want to push that commit I made to the alt timeline here. I'm also going to get rid of this one so it's an actual representation of what we're working on. I'm going to say git push -u origin. This might get a little hard to see. Alt timeline. Now you only have to do this -u origin and then the name of the branch. That's what the git -u origin master was doing. You only have to do that whenever you create new branches, because when you create a branch on your machine, it's only in your repository, and you have to connect your branch on your local repository to a branch in the remote repository. And that -u origin master just tells the remote repository to also create that branch and connect it to your local one. So that's what that part of the command was doing. Hopefully that makes a little bit more sense now. So now, if we go into GitHub and refresh the page here, let's go back into the overarching view. You'll see master has that new file here, but our alt timeline file is nowhere to be seen. If I switch to alt timeline, you'll see now we see that alt one, but not the new one. The projects are in completely different states, alternative timelines, right? So now let's talk about merging our changes in. So after we merge our changes in, we should expect to see all 4 of those files, not just 3, right? So every change is back in that main timeline. So to do that, let's jump back in here. So as the person who wants to do the merging, I'm going to check out the master branch. So I don't know if I haven't shown this off yet. So git checkout, the git checkout command is normally how you switch between branches. So if I want to check out the master branch, that's how I do it. And then the -b flag before the branch name creates a brand new branch. So at this point, I need to pull in my coworker's changes, right? So I'm going to do a git pull. And now I'm ready to merge my alternative timeline back into the main one. And to do that, I check out the branch I want to merge into, and then I type git merge, and then the name of the branch I want to merge in, so alt timeline. Now, something you'll also run into is you might see a screen that looks like this, and it'll probably be really confusing. What's happening here is when Git is trying to merge this in, it actually is making a brand new commit right here, okay? And that is the commit that basically adds all these other commits in. And the reason that's important is I remember how I said that all commits have to have a message? Even that one has to have a message. And normally we could get around this thing by doing that -m and then passing in the message. But because we didn't give it a message, what it's done here is opened up an editor. This is an editor that runs inside of your command line. By default on my computer, it's an editor called Vim. Now Vim is somewhat of a complicated editor, and it takes a little while to master. But you will probably accidentally run into this, and especially if you're merging, you'll probably run into this, so I'm glad that it happened. If you want to get out of this editor and save this message, by default it's added this merge branch alt timeline message. Everything that begins with a hash is just a comment that's giving you some instructions. To get out of this editor and save this message, you type escape, and then the colon, WQ, enter. I know that's probably very confusing, but there's a lot of jokes about how to exit Vim, and this is how you do that, because it is a little bit complicated. But essentially, what this little colon WQ does is tells Vim to save the current file that it's editing, which is this Git message. So you will probably run into this a few times. I know I ran into it, and I was always like, how do I do? Do I just need to like exit out of my terminal? Like I'm a little lost here. But that is how you do it. You hit the escape key, type :WQ and hit enter. If you run into that again, the thing to Google is just how to exit Vim, and that's how you can find those instructions again. So now we've made another commit here, and if I go to GitHub, we won't see that yet because the commit was only made to my version of the repository. Now I need to sync it back up with GitHub. So to do that, I'll type Git Push, and if we jump back to GitHub and refresh, right, we're still looking at the old branch. Once you merge a branch in, Git doesn't automatically delete it. That branch stays in the state of the last commit. So that's another thing to note. That's why I didn't see the change here. But if I switch back to master, we now see all 4 of those files from all the timelines, and that's where we are right now. And we can actually get a visual representation of this timeline in GitHub by going to Insights, not dependency graph, network. And we can actually kind of get a little bit of a visual representation here. So here's all the commits that I made. Here's the one in that other branch. Here's the one my coworker made. And here's the one that merged the 2 branches together. So is there any questions about branches? After that, I'll get into your file thing. Hopefully all this makes it. Go ahead.
Oh, wait, no.
Okay, sorry. Okay, so now to talk about your example of what happens when you and your coworker edit the exact same file. The good news is Git does a really, really good job here of not running into any problems. Where you will run, so the things that will work like normally kind of out of the box where you don't have to do anything and it'll just work, is if maybe I make some changes to a few lines of code at the top of the file, and then my coworker makes some changes to a few lines of the file towards the bottom. If we're in completely separate portions of the file and we're not editing the exact same lines of code, we'll actually be totally fine, because Git doesn't track changes on a file basis, it actually tracks them on a per line basis. So when you're making a commit and staging things, there's actually ways to go in and just add individual lines of code instead of an entire file at once, which is also really cool, but we're not going to get into that tonight. But for the most part, you don't run into problems there. Now, when you both do edit the same line, when you go to do a merge, or if you go to pull in some commits that have made modifications to files that you've been working on, Git will go into a, what they call, I think it's called merge conflict mode, where it takes the portions of the files that it has issues with and puts one on top of the other, both versions, your version and maybe your coworker's version. And then it's up to you to go in and manually edit the file to come up with kind of the final result there, to kind of fix all those merges. Because at the end of the day, Git can't tell automatically which of those changes are the right one, right? You kind of have to be the one to decide. You understand how the code works. Git really doesn't, right? Git's just tracking changes to a file. Let's see if I can, we don't have enough code files here to really do a super great example. But there's definitely some good stuff on YouTube of like how to go through a merge conflict. So that's, the best thing I can do here for you now in this presentation is just give you the name of it. It's called a merge conflict. And so you can use that to kind of Google your way around and find some YouTube videos on how to go through that. But once again, Git is just going to kind of have 2 blocks of text, one that's the original, one that's not the original, or that's the other person's, and then you have to manually kind of merge them together, right? Does that make sense at all?
Sounds very similar to Compare and Visual Studio.
Okay, yeah, it's definitely a lot like that. Yeah. So the last thing I'm going to touch on tonight, and I'm not going to go deep into this at all, is if you find working in the command line a little bit confusing, if you don't use this normally, you'll definitely probably find it confusing. But even people who are somewhat adept in the command line, this Git stuff can get a little bit confusing. It is really nice to be able to like visualize things like this, right? And so there are tools out there to help you do that. A really popular one is called Git Kraken. Git Kraken. It's free for the most part. It has some paid features. But when you open up Git Kraken, it will show kind of this timeline going straight up and down of all the commits you've made and the different branches in your project. And also give you the ability to make commits and push them up to Bitbucket or GitHub, or pull them down from Bitbucket or GitHub. Another really popular one is Github Desktop. This one's provided by GitHub. It is probably one of the easiest to use. Git Kraken has almost all the same features as Git itself. We've only scratched the surface in the things that Git can do here. It's a very, very powerful tool. And Git Kraken gives you a lot more of that power. GitHub kind of tries to simplify it down as much as possible, and it's a great way to get started if you're trying to work with Git. I know that there's another one called SourceTree from the Bitbucket team. That one's, I would probably stay away from that one. That one's a little bit more complicated. Your best bet is probably the GitHub Desktop app and the Git Kraken that I mentioned earlier. So, with that being said,
With GitHub Desktop app, would you begin with a GitHub Online account and work down to the desktop or vice versa?
To use the GitHub Desktop app in the first place, you have to have a GitHub account.
Yeah.
I'm pretty sure you have to go to the website to create the account initially.
You do.
Mhm.
I've done those steps already.
Gotcha.
And then you have to go through the webpage first, set up your account, then download GitHub Desktop.
Mhm.
Because then you have to log in, and then it makes the connection between
Right. It does some of
online
this.
repository
Right.
and your computer.
Yep, it does a lot, yeah, like she mentioned, it does a lot of that stuff, that connection stuff for you. I know that I'm pretty sure the GitHub Desktop UI, it shows all of the repositories that you have on GitHub, which is very handy. I also didn't really go too deep into GitHub, but something I will say about that is GitHub is full of all sorts of features built on top of Git. So, also GitHub has kind of been the fuel behind so much open source recently, because GitHub allows you to put your code out there publicly. If any of you are looking for like a job, one of the best things you can do is start putting the code for your projects up on GitHub, because then it's a social profile that people can go to for proof that you know your stuff, right? They can look through the code you've write, and once again, like, it's proof, right? It's kind of your credentials almost to get into a job somewhere. So if you don't have a GitHub, would highly recommend creating one. And then the other thing that it allows you to do is help on other popular open source projects. There's thousands upon thousands of projects up on GitHub. All the code is there for people to read. And you have the ability, through some additional features that GitHub has made, to provide your own changes to those projects. And the people who own those projects, they can merge those changes in. I have a couple of commits in some open source projects. Usually something simple, like when I first got started, I was learning the Angular JS framework, or specifically the Angular framework. And I noticed that they had like some spelling typos in their online documentation. And all the code to run their documentation website, including the content for it, was up on GitHub in their repository. And so I submitted some changes to fix those, and they got merged in instantly. So I have a couple of commits in Angular, right? And it feels really good to commit to open source. I love doing it in my free time, and I would highly recommend that you take a look at doing that kind of stuff, or just publishing your own work on there, because once again, it's kind of a credential. Employers will definitely look at your GitHub to see if they can find anything more about you from that. So, you're good to kill the stream. All right, go ahead.